So far, a function has been a thing you call. In Go, it is also a value, exactly like a number or a string. You can put one in a variable, hand it to another function, return it, or keep a whole collection of them. This is the foundation of an enormous amount of idiomatic Go. Sorting, HTTP handlers, middleware, callbacks. All of it is this one idea. Here is the whole idea in one line. F : equals double. We are putting the function itself into a variable. And the crucial detail is what is missing. There are no brackets after double. Double with brackets would call it. Double without brackets is the function value itself, sitting there, uncalled. Now, f holds that function, and f of 21 gives us 42. F and double are two names for the same thing. If a function is a value, it must have a type. And here it is, written out in full. Func, open bracket, int, close bracket, int. Read it as a function that takes one int and returns one int. That is the whole type. No names in there, just the shape. Which means any function with that same shape can go into this variable, whether it is called double, or triple, or negate. That is what makes the next part work. You can accept a shape, and let somebody else decide which function fills it. You can also write a function without giving it a name, right where you need it. This one has no name in its declaration, it is just func, brackets, body. And we assign it straight into square. The second one is stranger, and worth looking at carefully. We declare a function, and then call it immediately, on the spot. Look at the end. That open bracket, hello, close bracket, is hanging off the closing brace of the function. So it is declared and run in one go, and prints, ran immediately, hello. That shape looks odd now, but you will see it constantly in the concurrency module, where go func brackets body brackets is how you start a Go routine. And now the part that makes this genuinely useful. Apply all takes a slice of numbers and a function. Look at that second parameter, it is called f, and its type is func int. The shape we just met. Inside, apply all walks the slice and calls f on every element, collecting the results. And notice what apply all does not know. It has no idea whether f squares things, negates them, or adds one. It knows how to walk a slice and collect results. What to actually do is left entirely to whoever calls it. Here it is being used, and this is where it pays off. We pass an anonymous function that squares its argument and get back 1, 4, 9, 16. Then the very same apply all with a different function, and now everything is negated. One implementation of the walking and collecting. Any transformation you can express. Without this, you would write apply square and apply negate and apply double, each one a copy of the same loop with one line different. Same shape again, with one change. The function passed in returns a bool this time. A function that answers yes or no about a value has a name. It is called a predicate, and the word turns up a lot. Filter walks the slice, asks keep about each element, and builds a new slice from the ones that said yes. Pass it a predicate that checks whether a number is even, and you get the even ones. Pass it one that checks for greater than 5, and you get those instead. Filter itself never changes. It is the same 6 lines forever. When the same signature keeps showing up, you can give it a name with the type keyword. Validator is now a real type in your program. It means a function that takes a string and returns an error. And look how much better the check function reads because of it. Check takes a name and a validator. That tells a human what is going on far better than func open bracket string close bracket error would. It also gives you somewhere to write documentation, which a bare signature does not have. And notice the guard clause shape inside, with the if statement declaring error right in it. That is 3 ideas from earlier videos, all in one line. The standard library does exactly this. HTTP.handlerFunc is a named function type, and it is why Go web code reads the way it does. And here is where you will actually use all this, probably on your first day of real Go. Sort.slice takes your slice and a function that answers one question. Should the element at position I come before the element at position j? Say yes when word I is alphabetically before word j, and you get alphabetical order. Change that one function to compare lengths instead, and the very same call sorts by length. Fig, apple, banana, cherry. One sorting implementation in the standard library. Any ordering you can express, because the ordering is a value you hand in. There is one more thing functions as values unlock, which we are skipping for time. A map whose values are functions, giving you a compact dispatch table. It is in the written lesson if you want it. 4 things to keep. A function name without brackets is the value itself. Add brackets and you are calling it. That one character is the whole distinction. The type of a function value is its shape. Func, the parameter types, the result types, no names involved. Taking a function as a parameter is how you write one implementation and let the caller decide what it actually does. And when a signature repeats, give it a name with the type keyword. That is the toolkit. Sorting, filtering, handlers, middleware. They are all this. Your turn. Finish count if. It takes a slice of numbers and a predicate and returns how many elements satisfy it. Then call it with a predicate matching numbers greater than 10. Pause and write it. Here is the answer, and it is the filter shape with the collecting taken out. Walk the slice. Ask the predicate about each element and count the yeses instead of keeping them. Called on 4, 12, 9, 30, 11, and 2, with a predicate of greater than 10, the answer is 3, 12, 30, and 11. And once again, count if does not know what greater than 10 means. It just counts whatever the caller says yes to. That is functions as values. Next up, and it is the last video in this module, what happens when one of these anonymous functions reaches out and grabs a variable from around it? That is a closure, and it is how you build a function with a memory.